Welcome. Today we will explore how ISO 55000 applies to CANDU and SMR nuclear power stations. Both technologies operate under strict safety and regulatory environments, but each has unique engineering and asset management requirements. Let's dive in. Imagine managing a city where every building runs 24/7. Every road must never fail, and every system from water to electricity, from hospital to any industrial zone must operate flawlessly for decades. Now imagine that the core of this city produces enough power to light millions of homes and industrial places, and must do so with near perfect reliability. This is the world of nuclear asset management. ISO 55000 gives us the playbook to operate these cities of energies. Whether it's a major heavy water canned reactor or next generation SMR engineered for modular precision and passive safety. ISO 55000 is the fundamental document of the asset management series. It provides the principles and terminology needed to optimize value, performance, and risk across all assets. In the nuclear sector, ISO 55000 strengthens asset management by ensuring every component, such as CANDU pressure tubes, heavy water systems, SMR passive safety modules, digital control systems, and steam generators, is managed in the alignment with plant's safety case, regulatory expectations, and long-term performance objectives. By standardizing how inspection data is analyzed, and how risks are prioritized, and how lifecycle decisions are justified, ISO 55000 helps nuclear operators maintain safety, reliability, and predictable output across decades of operation. Asset management is more than maintaining equipment. It's a kind of strategy, and this is strategic discipline focused on maximizing the value that assets deliver over their entire life cycle. By applying these principles, organizations can reduce downtime, improve performance, and control costs, and make stronger evidence-based decisions. Actually, in nuclear operations, this becomes even more critical. CANDU reactors face aging and material degradation challenges such as pressure tube wear removal and feeder thinning and heavy water system corrosion, while SMRs produce new concentrations driven by digital controls especially. Modular construction and highly automated operating models, one of the key factors. ISO 55000 provides a structured approach that helps both reactor and different reactor types and maintain safety, reliability, and long-term performance throughout their operational life cycle. ISO 55001 operationalizes ISO 55000 by defining the specific requirements for an asset management system structured under the ISO NXSL framework. Together, these 7 elements create a comprehensive system that drives continuous improvement, strengthens risk control, and ensures assets are managed consistently across their full life cycle. In the nuclear sector, these principles directly support safety and long-term performance. ISO 55000 ensures that decisions are transparent and traceable and fully aligned with regulatory obligations, providing a disciplined framework that reinforced both operational integrity and safety assurance for CANDU and SMR technologies. To comply with ISO 55000, organizations must clearly understand their operating environment, specific risks, stakeholders, and business objectives. This ensures that the asset management system is both relevant and fully integrated with corporate strategy in nuclear operations, and this alignment is even more critical as these steps must connect directly to the safety culture, quality assurance, and frameworks, and stringent regulatory controls that govern plant design, maintenance, and long-term operation. Another critical point is leadership is needs to central to ISO 55000, and executives must provide clear direction and adequate resources to ensure asset management is deeply embedded within the organizational culture. Accountability structures must be well defined to prevent gaps in asset governance and decision making. In CANDU reactors, this leadership commitment is vital due to unique aging mechanisms such as neutron embrittlement, hydrogen ingress, feeder thinning, and heavy water leakage, as I mentioned before. This significant risks for the systems. Effective asset management must continuously monitor and address these challenges throughout the plant's operational life to maintain safety and reliability. There are also some critical safety systems specifically needs to observe, understand deeply STS 1, 2, ECCS, and shutdown cooling systems. Those are some of the critical items. ISO 55000 emphasizes proactive asset management planning. Organizations must establish clear objectives that link asset performance with risk management, including comprehensive life cycle planning, failure mode analysis, and emergency preparedness. Small modular reactors, SMRs, introduce unique factors with high modularity and passive safety designs, which reduce operational staffing requirements, but on the other hand, it increases dependence on supply chain reliability, digital control systems, and integrity of modular components. Conversely, CANDU reactors benefit from decades of operational data that help understand and mitigate risks like pressure tube degradation and heavy water system challenges. SMR risks, however, are centered around digital systems, modular fabrication complexities, and uncertainties inherent in emerging technologies, requiring tailored asset management strategies under ISO 55000 crucial. Operation and support under ISO 55000 isn't just about keeping machines running. It's a full ecosystem on the support side. You need competent staff, accurate asset information, sufficient resources, and well-documented processes. Operationally, you require tailored maintenance strategy, PM corrective and predictive rigorous change management regime, and tight control over any outsourced work. You need to do your own due diligence to control the outsourced work. Under an ISO 55000 aligned asset management system, this becomes especially critical in nuclear settings. For instance, in CANDU plants, IAEA TechDoc 1138 reports that maintenance programs have evolved from purely preventive to include predictive or condition-based methods, like vibration monitoring, thermography, oil analysis, and valve diagnostics, resulting in better system availability without increasing the maintenance burden. To dive deeper, here's how the maintenance and reliability framework might look in a nuclear asset management context. Risk-based maintenance, RBM. The reactor core components in CANDU reactors, aging mechanisms such as feeder pipe thinning are closely managed. According to IAEA TechDoc 1554, licensees are required to perform annual inspections of feeder thinning to validate degradation models and manage failure risk. And steam generators life cycle management plans track tube integrity, fouling, and corrosion as described in national safety reports. For example, the Canadian Nuclear Safety Regulators report outlines how they use inspection and water chemistry monitoring to control steam generator degradation. Safety-related systems must remain highly reliable. The shift to predictive maintenance for safety-critical components has been implemented successfully in Canadian plants, improving performance without compromising safety, one of the key factors. And predictive and condition-based monitoring, vibration thermography. These are used for rotating equipment to detect early signs of wear, of imbalance or other factor. As noted in International Atomic Energy Agency documentation, such diagnostic tools are part of the advanced maintenance programs in CANDU. And chemistry monitoring in heavy water systems, especially water chemistry in continuously monitored to prevent corrosion, hydrogen ingress, or fouling. A key part of aging and reliability management. Other factors. Neutron flux monitoring, while not always labeled as condition monitoring. Reactor core surveillance helps detect anomalies or degradation in core behavior over time due to neutron flux effect and on the instrumentation especially. Feeder thinning UT inspections are as required by Canadian regulatory guidance and IAEA based safety management frameworks. CANDU feeders undergo ultrasonic testing, short names UT, to measure thinning and validate degradation models. And digital diagnostics for SMRs. For advanced SMRs in situ diagnostics are critical. IAEA guidance MPT 3.19 on instrumentation and control systems highlights the need for prognostic and diagnostic capabilities built into design to support long-term maintenance and condition monitoring. And long-term life cycle planning, MCR planning for CANDU major component replacement. MCR is part of long-term strategy for CANDU reactors. During refurbishment, for example, retubing, feeder replacement, utility operations plan for multi-year project cycles, coordinating outage inspections and life extension activities. Modular replacement cycles for SMR. SMR designs often incorporate modular components that can be factory built and replaced or refurbished in modular. This modularity simplifies lifecycle planning but demands too robust asset management plan that covers part replacement, supply chain and coordination especially, and long-term condition monitoring. Configuration control, digital INC versioning for SMRs. Digital instrumentation and control systems must tightly manage the International Atomic Energy Agency's instrumentation and control systems for advanced SMRs. Code name is MP-T-3.19. Explicitly stresses version control, verification, validation, and configuration management over the life of the plant. Other aspect is change management approvals. Any change to configuration, hardware or software must go through rigorous change control, especially for safety critical instrumentation and control systems. Regulatory documents for SMRs also emphasize the need to maintain traceability of changes back to licensing basis, especially on Canadian Nuclear Safety Commission and Canadian Nuclear Safety Commission documentation. Reliability for safety audits. All changes must be fully documented, versioned, and auditable to satisfy both international governance and external regulations as well. This includes maintaining a documented history so that every modification links back and safety justification and licensing based. In real-world nuclear operations, these practices are not theoretical. They are central to managing risk, optimizing plant uptime, and ensuring long-term safety. ISO 55000 structure help embedded them in a way that's strategic, auditable, and aligned with regulatory demands. ISO 55000 requires organizations to measure performance, conduct audits, and review systems. Issues are corrected and updated are implemented, creating a continuous improvement cycle that keeps the asset management system effective and value-driven. In nuclear operations, continuous improvement is mandatory, and ISO 55000 ensures that lessons learned, documentation, and performance assessments are fully integrated into the long-term asset strategies, supporting safety, reliability, and regulatory compliance. ISO 55000 provides a structured approach to maximize value from assets while supporting organizational goals. At its core, it aligns the asset management system, AMS, with corporate strategy, ensuring leadership and governance responsibilities are clearly defined. Executives must provide direction, resources, and accountability to embed the asset management into organizational culture. Understanding the organizational context and stakeholder expectation is essential, and effective AMS considers risks, regulatory obligations, and long-term impact of decisions. Risk-based decision-making and lifecycle management ensure that all assets from critical reactor components in CANDU plants to modular systems in SMRs deliver optimal performance throughout their life. Performance monitoring, measurement, and information management support transparency and informed decision-making, crucial also. Staff competence and awareness are key, supported by financial and resource planning to maintain safety and reliability. Operational control covers maintenance strategies, change management, and supplier oversight, ensuring outsourced activities meet quality and regulatory standards. Finally, ISO 55000 emphasizes continuous improvement, corrective actions, audits, and management reviews provide assurance that the AMS evolves and evolves with operational needs. Lessons learned and regulatory requirements sustaining value, safety, and long-term performance. In managing nuclear assets, different reactor technologies, unique critical elements that must be monitored and controlled under ISO 55000 principles. Especially on the CANDU has some critical elements, and I try to itemize this one. And first one is pressure tube integrity program, ensures reactor core components maintain structural and safety integrity. This is the key item. Feeder thinning management, other secondary aspect, monitors and mitigates aging of feeder pipes to prevent failures. Other one is heavy water system reliability, maintains moderator and cooling system performance. Another one is steam generator and heat transport integrity, protects primary heat transport system from corrosion and tube degradation. Aging management and fitness for the service, assess components for life expansion and safe operation. Safety system readiness, STS1, STS2, ECCS, ensures emergency core, cooling, and shutdown systems remain fully functional. MCR planning and extended operation strategies, long-term planning for major component replacements and refurbishment cycles. And SMR critical elements, on the other hand, modular fabrication quality assurance ensures factory built components meet design and safety specifications. Passive safety system integrity guarantees reliability of passive cooling and safety features. Cybersecurity and digital control system reliability, this item quite governmental strict rule content attribute. Protects critical digital instrumentation and control systems. Multi-module asset coordination, managed operations across multi-reactor modules. Factory to the site supply chain controls. Tracks components from production to installation. Modular replacement strategies, plans to scheduled module replacement or refurbishment. Novel materials, technological qualification, variables, new materials and technologies under operational conditions. And by focusing on these critical elements, ISO 55000 ensures with CANDO and SMR plants achieve long-term reliability, safety, and optimized performance, while aligning asset management with strategic and regulatory goals. Thank you for joining me on this deep dive into ISO 55000 and its role in managing CANDO and SMR nuclear assets. I hope this video helped you to understand how strategic asset management supports safety, reliability, and long-term value in the nuclear, especially industry. Thank you.